Hey, welcome to Flight Test. I'm Josh, and today we're going to be showing you how to build the race quad version of the VersaCopter. Now, if you've never seen the VersaCopter before, it's actually one frame that can support 8 different layouts and also 2 different sizes, from race quad all the way up to AP ships 400 plus size. Today we're going to be showing you how to build the quad. Now, if you're commonly used to seeing us use a lot of wood dowels, this kit actually is featured mainly around carbon fiber tubes. It's very versatile, very good, and we have a purpose for that we're going to be showing you in the near future. If you haven't seen the review of the VersaCopter, check it out now. There'll be a link below. Let's go ahead and get our materials and get started. Now, the first thing we're going to do in building the VersaCopter is soldering the ESCs and all of our connections. That's not too typical normally, but in this case it's going to be very easy to get this done right off the bat. Now, the VersaCopter can go up to 6 motors. Since we're doing the quadcopter version, we're only going to need to use 4 of those. So we're going to be building this with PowerPack E. PowerPack E has 12 amp ESCs, BL Heli, and 2204 motors. It's a wonderful setup for beginners all the way up to intermediate. Lumineer puts out an amazing power pack. The build sequence is going to be the exact same, but they have features like auto shot and a much more powerful motor that gives you a greater performance. Alex Zavada truly loves that pack. So we're going to go ahead and get our wire stripped down. The 12 amp ESCs that come in our power pack E are right here. Now you're going to notice that there's a JST. We're going to want to go ahead and remove our little label, and we're going to want to trim off our power cable. And you can save this if you want and solder it on something later. And then we're going to strip the ends. Now these wires are short. You can actually just pull it off with your nail. Just over 1/8 of an inch. We're going to do that on all 4 ESCs. We're also going to be soldering on our main power cable right now too, but we're going to do our ESCs first. Now if you look closely, you're going to see ESC 1, 2, 3, and 4. And you're going to see the positive and negative. We're going to want to solder the red to positive and the black to negative. Now, if you've never soldered before, we'll have down in the links below some really good videos on how to solder. So if you're a beginner, you don't need to be intimidated by this. You just want to make sure that you follow the proper procedure and get a good, strong joint. If one motor goes out on a multi-rotor, you're going to have a tremendous amount of difficulty flying at home. In other words, it won't fly. So to start out, we're going to do 2 things. I'm going to tint the solder pad. And we're also going to put a little solder on each one of the wires. Easiest way to solder is just put a little puddle right on the edge of your soldering iron and then let it wick into the wire, and then just feed a little bit of solder right into the wire. Once again, we have a video on that. If you've never soldered before, don't let it intimidate you. Now that we have everything tinned, I'm going to make sure I match the black to negative and the red to positive. I'm simply going to hold this down. I'm just going to touch the soldering iron right to it. Let the solder flow right up into it, become one joint, pull away. I'm going to repeat the exact same process on the other side. Now for your solder, you should want to see a nice shiny surface. If it's dull and dingy looking, you have most likely a cold solder joint. If you don't have enough solder on it, you can also just simply hold your solder and flow a little bit more in. Just like that. Now we're going to repeat the exact same process on the other 3 ESCs. We're going to do the ESC pads here, here, and here. You're going to notice nice strong joints. I would laugh my head off if that fell. That would have been so funny. Now oftentimes people like to use the helping hands, the little pinchers that will hold everything in place, but holding the PCB board is kind of difficult. If your soldering iron doesn't get hot enough to be able to hold it quickly and solder it quickly, you can always just use a piece of wood, like a popsicle stick, or we're using actually a dowel here, to hold this down and then hold your joint for you. That way you don't burn your fingers. There we are. Now one thing I'm going to do is I'm going to solder on a JST. This is a battery end. I'm thinking this would be considered male, depending on whether you go by the plastic or the holes, if you're going female, if you're going by the holes. But long story short, this would be what would be on your simple battery. I'm going to solder this here so I can connect different things. I could connect LED lights, or in this case, I'm going to put a video transmitter on it. Now if you have a video transmitter that can only operate off of certain voltages, or you have a camera that can only operate off of 5 voltages, you can get a Pololo board. It's very common on Amazon. GetFPV.com sells them, and you can solder it in place here, and you can actually specify what voltage you want to step down. So no matter what voltage battery you put on, whether it be a 3-cell or a 4-cell, you can always get a constant 5 volts or constant 12 volts. And that's really great for operating different equipment that doesn't have a voltage range that goes with your battery. So I'm going to go ahead and solder this on. I'm going to go on auxiliary 1 or auxiliary 2. In this case, I'll go ahead and pick auxiliary 1. And that way I can plug my video transmitter right into it, but if I need to service it later, I can unplug it. Keep in mind, the more connections you have to make, the more points of failure. So if you want to keep it light and simple, you can always just cut it off and hard solder it. But in this case, one little connection is not a bad thing. Say you have a really doozy of a crash, and you need to do a repair or swap out a video transmitter that goes bad, you can do that very quickly with no soldering. Same process as before. I'm going to match up the red to black, or red. I'm going to match up the red to positive. Touch it down. It's on. Black to negative. That's on. And we're good to go. Now in Power Pack E and also Power Pack D for the bigger multi-rotors, we're going to include this lead here. We prefer XT60s. Other people may fly off of Deans and ESCs, EC3s, but this is the most common one that we prefer, and I think it's also one of the safest ones too. So we're going to pass this through. Now you could just simply solder this on and have it hanging out and wrap it around and kind of zip tie it, keep it away from your props. With race quads, one of the most unfortunate things is that the motors are so close to the frame, it's very easy for these to get hit and cause problems. So we're going to do something a little bit different on the race frame. Now in bigger frames, we may very well have this just going out the side where you can plug down into a rail or something, but we're not going to do it in this one. We're going to pass this through this little oval hole right here. Now we're going to keep careful in mind here that here's the positive and here's the negative. We're going to want to make sure that the red and the black go down properly. So one thing, we could always trim this short and keep this really tight, but what we're going to do is we're going to actually give a little bit of relief to this. We're going to have this wire go up just like this when it's inside the frame. I don't really trust this solder from the factory. I'm going to cut that off. And I'm going to put new solder on new leads. Make sure you wind this up as tight as you possibly can get it. Reason being is if you have any air in there, it's going to act as an insulator and not let the solder fully go through. There we are. Just like the ESCs, I'm going to tin the positive and negative and also the wire leads as well. Now you can see, once I get the puddle started, I'm not feeding into the tip anymore, I'm feeding into the wire itself, and I'm letting it wick inside the wire. That's a good sign that you actually are getting solder all the way through the wires when you're feeding solder on the opposite side of your cable. Once again, getting the heat started, then pushing it into the cable itself. This is going to be what powers the whole entire machine, so make sure that this is really good. I'm going to use my faithful piece of wood here. Hold this down. I'm going to press this in. And you'll know you have a really good joint when you actually see the solder on the pads melt down in and you feel the whole thing relax right into the solder pad. Give it a good 15 seconds or so, let everything cool down, and you're good to go. You can see that I'm bringing these in from the sides. Reason being is when the frame's on here, I want this to tuck down nice and neat, as you see here, and give myself as much real estate as possible in the center section. It'll all make sense later on. You don't have to do it this way, but it just keeps things kind of neat.
Oh, it makes a little heart.
Makes a little heart.
Yeah.
How's that?
Nice.
Grab 2 zip ties that are included in the kit, and You can see here that this is going to wander a little bit on you. I want to kind of keep this fastened down so it doesn't pull up and cause this area to cut. Carbon fiber, different materials are all very conductive, and we want to keep that to a minimum. So I'm actually just going to take this, I'm going to pass this through. You don't have to do this, it's just a little trick. And I'm going to put this around the base of the connector. So I'm just going to cinch 2 zip ties here. I want this to be serviceable, so if we ever have to replace it, we can. But I also want to lock this down in so it can't pull out. Now if you really want, what you can even do is you can flow some hot glue around this area too and really lock it in nice and solid. At this point we're ready to start building our frame. Now just like all the other plates, if you built a Electro Hub before, you can actually sandwich this down. It does 8 different configurations and you don't need to build any frames around this. What we're building this around is our new Delrin frame that accepts round carbon fiber tubes. These carbon fiber tubes will give you a lot of benefit in the future. Very, very strong, but also light, and you can change your thrust angle, you can move your motors forwards, you can move it backwards, and if God forbid you do hit something like a tree limb or hit the ground, the motors will actually spin on the carbon fiber tube a little bit and cause less damage to the motors, the bells, and oftentimes keep the sticks from breaking. Now in the kit you're going to see 2 different thicknesses of Delrin. You're going to see one with these weird looking C-clamps, and you're going to see other that's thinner that has side plates. Go ahead and carefully pop these out and get them on the building table. Now the whole goal of this Delrin kit and the carbon fiber tubes is to keep everything on the inside. The things that you can keep cleaner but still serviceable and still accessible, the less damage you're likely going to have if you hit something or if you bump something. Our goal with this design was to make it DIY, but when you're done with it, it doesn't look DIY. Alright, now we're going to put our attention towards these C-clamps right here. Be careful popping these out. They push nice and even so you don't crack the clamp. They're very tough and durable, but anything's possible. These here are going to be later on when we put FPV gear on it. These are just kind of extra. You may not necessarily need these, but we're going to go ahead and pop those out anyway. You have 2 just in case in a bad crash you break it, because that is what holds your antenna extension cable and takes the strain off of your video transmitter. You can keep that if you want, but this is to help us. This is our board mount for inside, and this is to help us keep orientation. So we're going to take our little C-clamp tube holders, and there's 1 notch and then 2 notches. We're going to take our 1 notch, and with the little opening facing towards the radius edge, we're going to press this down on the table and pop it in. You may hear a little pop, but it's going to be just friction fit, nice and tight. We're going to do this on all 4 slots. You can see it's a little tight. We want that to be tight so you don't have to fiddle with multiple things at multiple times. We're going to take our side plates and just lay them in place. Now we're going to take the top plate and focusing on these back notches here, we're going to press them into place one at a time. Take your time with this. If you find you're putting too much pressure, it's probably because one of the tabs isn't lined up. There we are. We're going to do the exact same process on the other side. 1, 2, 3, and 4. And I'll go ahead and just open this up in a second. Do the front side. Starting in the back, then rocking forward. 1, 2, 3, and 4. Now with the radius side facing outward, I'll go ahead and pop in my little side plate. There's 1. There's 2. The whole idea of this is to be simple. You're going to have to push these together, but once you're done, you're going to see everything holds together quite nicely. Our next step on the frame is to install these little side supports. Now we're just going to simply take this in, and if you look here, the shape of it's kind of unique. These will just press in 2 each side. If you do it right, you're going to hear a little bit of a snap. We'll do that on both sides. One of our 30mm screws is actually going to pass through both of these supports and hold the center section in place. Now, if in future parts of this build video you see that there's only 1 slot, that was an earlier version. Since then, and on all the kits, we're going to have 2 slots. Now that our frame is done, we're going to put our attention to joining the frame and the PCB board. One thing we want to take a note on is you have large holes here and small holes here. Reason being is as the screw passes through, we want it to actually thread into this side. That way, when the PCB board goes in and you fasten it in, everything's held in place and it doesn't fall apart on you. Also, for servicing or adding on or modifying the multi-rotor, it's very easy now. You can pop it open, work on it, and put it back together right on the field for you. So make sure that these holes here are facing up towards you and that your PCB board is facing an orientation just like this. Before we put the PCB board on, let's go ahead and just pass the ESCs right through the center like you see here. Going to make routing wires a lot easier. Now I'm going to hang this over, kind of get all these hanging down as you see here, and now I'm going to change the orientation where the big holes are going to be going up against the PCB board. Rock that down in there, pass it right on through, just like that. Our next step is we're going to take our 30mm long screws. These are 2mm button head hex screws. And we're going to go ahead and drive these on through, and these are actually going to self-thread through this top plate, but we don't want to tighten them down too much because these screws are what are also going to be tightening down on the carbon fiber tube. If you tighten it too much, what you're going to find is you can't loosen it and you can't get your tube in and out. Pass this on through. On the front side, because we're going to be putting an optional camera tray on, I'm going to choose the outer hole. So you can see that we can actually use 2 different holes on here, and those are used for different reasons. We'll cover those in later mods in the future. I'm going to take our 2mm screwdriver, I'm going to screw this right on through here. Now, as I mentioned earlier, we're going to be using this in an episode, and I'm going to be putting FPV on this one that we're building here. So rather than telling you about FPV, I'm going to show it to you, and we're going to take this build process all the way up with video transmitter and all. There we are. Now, the nice thing about this is you may start off with a basic multi-rotor with no add-ons, no frills, but later on want to upgrade it. You can easily move these screws in and out without everything falling apart on you. Just going to back it off a couple turns, keep these clamps nice and open, as you see here. Now on the back here, I'm going to be putting a video transmitter in this. And what I would like to do is I'm going to be taking this little wire guide, I'm going to place it down right here in a way that allows this to pass right through the holes. So this also has a hole that needs to be threaded, and that's because we want this to stay on the very top of the plate. Now, say you had a really bad crash. You do have 2 of these, and we're yet to break one, but we went ahead and put 2 in there, mostly for symmetry, and the fact that we had the extra real estate on the Delrin. So you're just going to go ahead and screw this all the way through, and if say you broke this out in the field, all you need to do is take out 1 screw. You wouldn't need to disassemble your machine or anything. Pop the next one in. Once again, you're not going to want to tighten this down too much. I'm just going to back this off a couple screws. That way this isn't pinching down too tight. Last screw, I'm going to mirror this. Now you think that you'd really have to cinch this down hard? No, the fatty Delrin does a really good job gripping the carbon fiber tube, and I don't want it so hard that it's putting stress on the pieces. I only want them to grip, not try to crush. Now we're going to be hooking this up for FPV, and before we do that, one common thing is when you crash multi-rotors, you're going to notice that it puts a lot of stress on the video transmitter if your antenna is directly attached to it. So what we're going to do is we're going to take this little extension here that we sell, and we're going to pass this through before we put the tube in. We're going to pass this on through, let that cord hang. I'm going to push this right up through the top, and we're going to work this through. See, I'm not Bob Vila. There we are. Just like you see here. Cool. We're going to drop our little washer, this little nut here. We're going to tighten it down. Now all the stress is going to be on your antenna or this coupling, and if God forbid it breaks, most likely this guy is going to break here, or God forbid your antenna, but your transmitter is going to be just fine. Now keep in mind, when you power up your transmitter, if it doesn't have an antenna on it, you're going to blow up your transmitter most likely, so always keep an antenna on whenever possible. Now we're going to go ahead and put our attention into dressing up this area right here. For each ESC, we're going to pass the leads through, as you see right here. We'll do that on each side. You'll notice I'm keeping the ESC that's closest, so the hole is the one I'm using. Little race quads are notorious for not having much room, so we're really trying hard to give you as much real estate as possible in the protected area. Alright, so we passed everything through. Our next step here is to take some zip ties, and we're going to fasten this down. So we got some black zip ties right here. Now I want these little knuckles to be on the inside to make this look as clean as possible. So I'll go ahead and I'll just slide this up. Before I cinch this tight, I'm going to take this all the way to the bottom, and I'm going to draw it up in just like you see here. That way you only see that little black zip tie right on the outside, the knuckles on the inside. Now I'm not going too crazy tightening it up too much. That way I can move that little knuckle all the way to the bottom like you see here. I'm also keeping these wires free from being pinched. We don't want to over cinch this and have these wires pinched and cause heat problems. Same on the other side. Pass it through. Get it going. Loosely cinched. Cut the excess and tuck it down. Same process on the back end here. Now the front and the back end of the multi-rotor are open, so airflow can go through the fronts and go over the sides. So this flat area where the heat sink is, it's hopefully going to get a lot of ventilation. We've flown quite a few of these and had very good success and no overheat so far. Tuck it down. There we are. Now we can take these guys here, we can just go ahead and fold those down and kind of let the bottom of the ESCs hold them down, just like you see here. This open cavity is going to give you plenty of room to either put the GR18, which is a receiver and a control board combo, or you'll be able to put an ACE32 and also a receiver inside this cavity and still have all your wires nice and neatly dressed, nothing getting tangled. Now this is extra if you're not flying FPV or just getting a hobby, or you have a different mode of how you want to put your video transmitter. We're using the Lumineer. This is a 5.8 gigahertz, 600 milliwatt. Way overpowered for what we need it. The race bands and the 200 milliwatts is commonly what people are using on the in the FPV circuit, but this is what we had in stock. But the process for whether it's a 200 milliwatt or whether it's a 600 milliwatt is the exact same process. Now in this we actually have two different connectors, and because I'm not really a high energy flyer, I'm going to go directly out of my GoPro. There is a little bit of a lag with the GoPro, but for beginners, as long as you're not flying too fast, it's not that bad. It really becomes noticeable when you're going full speed between trees and some very, very hard to go through objects. That's when you're really going to notice the lag the most. So I'm just going to use this cable that's included right here. Now take special mind whenever you're plugging this in that you have negative and positive and then negative on the far end. So I'm going to match it up. There's my negative and positive, my video, and negative on the far end. Also there's some tangs right here that allow it to go in. You want to be very careful. This is a small connector, so make sure all your pins line up nice and neat before you plug it in. Next step that we're going to do is I'm going to tighten this onto the extension here. Now I'm going to press this through a little bit. My goal here is to fasten the video transmitter right on the side here so it gets as much airflow as possible. This 600 milliwatt gets very, very hot, and we don't want this to be directly over top of the ESC. We want the ESC to still be able to breathe. We want this back just a little bit. Also gives a little bit of a relief to this cable right here so it's not stretching anything. We're going to go ahead and take a zip tie and fasten it down the same way as we fastened everything else. Except this case we may need two, we'll see. There we are. Nice and fastened down. So now we can change our frequencies very quickly on the fly, and we also have a lot of air cooling. If we let this loose enough, we could pass it through right here, or we can even go up through this front here where the recess is. One thing to pay in mind though, if this is a pinch point and gets tight, it could cut this wire, so be very careful with that. I'm going to go ahead and cut this free. I'm going to pass these wires through here just so they're out of the way of getting cut. Just like that. Now I'm going to be putting a little I'm going to be putting a little camera plate on the bottom here. There's many different configurations, too many to show you in one video, but I'm going to show you the easiest mod that's the quickest. That'll give you a little plate to hold your GoPro and make things very clean. I passed the GoPro connection right through the front here. Once again, we're going to make sure that we keep this down below the tube as it passes through, but this is going to give us a nice ability to have a nice clean wire setup. Before we go any further, let's not forget to plug in our video transmitter. Like so. There we are. And we'll go ahead and, just like everything else, we'll just tuck that down in like you see here. Now there's two more screws that we're going to be putting in, and we're going to go ahead and do that now. We're going to take our two more 30mm screws, and we're going to thread it right through these side plates. That's going to give us the ability to keep these things from wandering all over the place when we tighten them down. There's one, and here's two. At this point, we're ready to put our booms in. Now it's really important here that these are not too tight. If they're too tight, you're going to have a very difficult time passing them through. I'm going to favor this towards the bottom, and I'm going to favor the ESC wires that I'm passing through towards this little cutout right here. Now these side dowel rim pieces are cut out so they'll receive either a square boom or a round tube. The only difference is the receivers, little C-clamps, have a square cutout normally in them. Alright, so we got the front pass through. We're going to pass through the back. You can see I loosened the screws quite a bit here, and I'm just holding it in place. Just allow everything to easily pass through. If you have to, you can always kind of set it down, but usually a little twist and it pops right on through. We're going to get this as close to center as possible. We can make our final adjustments when we put our motors on. Speaking of motors, let's tighten these down, and that'll be our next step. Okay, for the motor mount discs, these are going to press right in here, and they're not going to be the tightest at first, but once we put our motors on, they're going to get much, much tighter. The biggest thing we want to make sure is that both the open ends are facing the same direction. Just like this. We're using the Emax 2204s. Now we have two different styles. The black-headed screws are reverse rotation. Reverse rotation screws go on reverse props, and reverse props spin clockwise. So we're going to make sure that when we orientate this, that we're putting this on the right side. We can do that later. Right now we're just going to concentrate on putting the motors onto the little motor mounts. To do this, we're going to grab two 25mm screws. Now before we go any further, we're going to want to take careful note of the spacing on the screws. We're going to want to put our screws through the 19mm holes. That's going to be the farther the two apart. If you put it through the 16, you'll scratch your carbon fiber boom. We're going to lay this right over top. One thing that's really important is to use Loctite. Now I'm terrible with this, but I've had plenty of crashes to teach me otherwise. So make sure before you put your motor on, take a little drop of Loctite, put on the very end of the threads. Once you screw that into the motor, it'll be easy to break free if you have to, but it'll hold it solid. We're going to pass the screw right through and just give it a couple little turns like you see here. We're going to do the same on the opposite side. Just like that. Now we can go back with our little C-clamps. We can slide them in. There's one. Opening in the front. If you can't fit your little C-clamps in, it's most likely because your screws are too tight. Just loosen them a couple threads they'll pop right in just like that. Now as far as mounting this goes, we're going to take a look at this. This is going to be the front, and our props like to swing in. So this is our conventional, this is going to be our reverse here. So we're going to mount this just like we see here. So once again with a little twisting motion, we're going to pop these on through. Little rocking back and forth, and she's on. Now I'm going to go ahead and just give this just a little quarter turn, just enough so it doesn't fall off. And we'll go ahead and repeat the process on the other side. So once again, the biggest thing that we're going to pay attention to is make sure we're using the 19mm hole spacing, not the 16mm hole spacing. We're going to have black tip, white tip, white tip. Alright, so all of our motors are attached loosely, but they're attached. Our next process is going to be to make our connections. Now, I want to stress right now, it's going to be very tempting to rush ahead, connect things, put props on. You're going to want to leave your props off at all costs. I know it'll look finished when we do this, but it's not safe. So keep your props off, but our next step here is to make our connections. Now, there's really no rhyme or reason. When we put the control board on, we'll know if this is spinning the right direction. So just pick any three that you want. To make this make your motor spin the opposite direction, all you simply need to do is swap out two connectors. And I'm sure one of these is going to be backwards, and I'll be able to show it to you. Alright, now obviously this is not something we would want with it flopping up. Once we go ahead and we figure out which way this is going to go, we're going to clean this. For now, we're going to just keep these just pointed down just a little bit. Let's go ahead and flip this over and put our attention now back towards the control board. At this point, we're ready to actually put the control board in. Now we're going to be using the GR18. It's not the 18L. The 18L does not have the gyros in it, but this is a GR18. An amazingly good value. You have 9 channels. And on top of 9 channels, you also have telemetry, and you also have a control board in this that can run everywhere from a quadcopter, a tricopter, and a hexacopter. There's another version of this that can also run airplanes. We'll cover that in a later video, but this is a $99 Graupner GR18. We're going to put this in. That's going to be both our receiver and our control board, and enough with the pitch. What I like to do is, I don't have the computer right here. We don't need the computer to program this. We program all through our telemetry link. So I actually took a snapshot of the configuration number. Now right now the multi-rotor is on its back, but I want to show it to you, the order. The order for the multi-rotor is going to be, front left is number 1. So what I'm going to do is I'm going to grab this right here, and I'm going to plug it into channel number 1. The ground is on the bottom. Number 2 is the front right. So there's my front right. And I'm going to plug it in to channel number 2. Next one is going to be the back right. Here's my back right. And obviously the last one here is channel number 4. It's very difficult if you're holding everything upside down trying to switch things around in your mind. It's also very important that that's why you don't put props on, and that we do our run-up test beforehand. But this here is all the hooking up we need to do to fly this multi-rotor. Everything is set to go. So we're going to go ahead and we're going to set this down. Now this comes pre-flashed with a quadcopter. There's virtually no tuning that's needed to be done if you're running this stock setup with the e-pack. The biggest thing is that we're going to face this forward with the antennas facing forward and the bind button facing up. Now right now a lot of people are probably wondering why this is in the kit. This is actually going to be our mounting plate for either our GR18 or our NACE 32 board. And this mounting plate can actually clip in right here. It's not quite right over the center. If you do want to have something right over the center, you can always mount your GR18 to this plate here and have it travel. But one thing I like is I like being able to service this, remove this, open up the plate, and have this complete cavity in here to do all my soldering here. You can see it's wide open. If we didn't have this bottom plate, we could darn near put our battery right in there, but we wouldn't really want to do that. So I'm going to go ahead and cut this little piece of two-sided tape here to length. I'll place it right on the back here. Now this is a learning system here. I'm going to show you a couple things that are beyond what you need to do, just so you have some knowledge of how the Graupner works and how to do some adjustments on it, because you may have an application where you need to mount your board this way. The nice thing about this is the learning system. You can actually put this through inputs where you give it an input and tilt your multi-rotor a certain way, and it learns and automatically programs itself, and it's amazingly easy. I'm going to peel this double-sided tape off now. You guys are going to notice that there's a little gremlin on this plate. The reason I put this here is because this could pop in either way, and we're not sure which way that we want to go. I'm going to go ahead and mount this in a way so whenever I see the gremlin and it's facing on its back, I know which way to put it back in. I'm going to just favor this right at the back end here. Nice thing here is, say you need to bind, you can flip this over, you can do your bind process, and then you can pop it right back in. And then this will just clip in here. Now there's extra zip ties in your kit. What you can do now, if you want to keep it nice and clean, I'm going to actually snake these wires through here. I can bundle this up together and put it in a nice little ponytail. Before I have this down, I'm going to make sure all the wires are favoring the one side here. Actually, I can pull that out. Just like so. Clip this down in. Pull this forward, and then just very lightly cinch it, like that. Let me just pass this right under here. We got a very nice, simple, clean setup. And if you need to service it for any reason, you have plenty of room to get to everything you need. Before we go any further, now would be a really good time to put our battery strap on here. We're going to strap our battery to the outside, not underneath but on top this time. And in the kit, we have some simple little Velcro straps. Now a really fantastic upgrade is these Lumineer straps. We're going to be carrying these in the store in the near future, whether it's Lumineer or Flite Test, but this is wonderful. You simply pull it down to the buckle, and then when you pass your battery through, you can pull up tight and fasten it down. Look for those to be out within a month. But GetFPV.com sells them right now. So before we put the control board down in its final position here, I'm going to pass this through, right through the bottom slot. And out the other end. Just like that. Alright, so we're going to make sure our gremlin is facing up. We're going to line the two little tabs up and clip it down into place. Now before we close this up, you can see we have a lot of excess wire here. I'm going to go ahead and very carefully, and I'm not going to force it, take the tip of my screwdriver, and I'm going to kind of work my way down here and kind of grab the loops, almost like I was crocheting. I'm going to rock it back and forth. What I'm trying to do is I'm wanting to work these bullets as close as possible to the side of the frame. And what I'm going to do is I'm going to fasten these bullets right here with a zip tie. And these will stay in place, and if we need to change the orientation, all we need to do is pull it out and put it in. Also, if you have a really bad crash and this gets broken or knocked off, these will hold in and they'll unplug at the bullets for you. It won't put any stress on these wires. So we're going to do that on all four sides. Just work one wire at a time. Kind of wiggle it back in. What I'm doing with my finger over here is I'm just kind of helping things along, finding their place in there. Getting as close as possible to the inside. I'm really not pulling these through, I'm just kind of guiding and wiggling them, and then I'm letting my fingers kind of work them in. There we are. This last side's the tightest. If you have to, you can always slide back your ESC just a little bit. So at this point here, these all the way back in the way I like it. Little zip tie, knuckle at the bottom. Wrap it around. Now I'm going to cinch it right over top of these barrels here, like so. I'm going to repeat that same process on all four sides. So now we can do final dress up after we get the motors spinning in the right direction. So we're going to go ahead and install this. Once again, we're going to look at our gremlin. We're going to match our gremlin here to our gremlin there. That way we know we're putting the board in at the right orientation. Clip it down into place. Before I close up the lid, we have two. This is a diversity controller, which means it has two antennas. I'm going to go ahead and pass one. Let's see here. I'm going to pass one right through this hole right here. Just out, just enough to get the antenna out. I'll close that up. And with diversity antennas, you want the antennas facing 90 degrees. So you want one, say, going vertical or sideways. But you always want it to be 90 degrees to the other one. You have two different sides to the plate. It can go on either way. Just pick the logo and what you want to see the most. Make sure none of your wires are pinched. Slide it on. Just like that. Now I'm just going to thumb tighten two nuts here. I'm going to do it in the middle because I'm going to add an optional little camera tray here. We'll talk more about that in just a second. So we're going to plug in the linear antenna here. That way we can power the system on. No props on there. We're going to turn this on. It's already bound. And I'm going to go grab a battery. So we're going to power this up here. I'm just going to go ahead and hold this down for the moment. No smoke, that's a good sign. Now this is actually arms after 3 seconds of not moving. This actually arms. Everything is fine, very nice, but I'm still going to show you how to do the proper calibration on both the accelerometers and also the ESCs. Now I'm using the MZ12. Graupner's come out with a really great combo for about 199 bucks. It's a 6-channel radio with multi-model memory, wireless telemetry, wireless buddy box, and everything that we use very commonly, but it's also paired and already bound to a GR18, ready to go in quadcopter mode. So if you get that combo, all you need to do is make your connections, tape it in, and do 2 settings, and you're ready to go. On the MZ12, you have 4 little buttons here. We're going to press the TLM, which is telemetry. And then right there we have system and data settings. We're going to hit enter. Now we're going to go ahead and use the cursor on the left side, and we're going to hit over until we see our calibration position. We're going to go down to calibration. We're going to enter. We're going to hit up once. And did you see how it went from yes to no? We just calibrated our accelerometer. Now it knows what level it is. So God forbid, say you tape this and it was slightly crooked, it's now adjusting for that. Now we're going to go ahead and we're going to go over, we're going to unhighlight this by hitting enter once. We're going to go over. And this is kind of cool. You don't need to do this, but I want to show you this. This is so cool. It's a learning system. It says do setup for gyro assignment. We're going to hit enter. We're going to highlight yes. Now, what I'm going to do is I'm going to move my stick to the right. See how it highlights +2? That's bank to the right. So now I'm going to bank this to the right. Once I cross 45 degrees at the right bank, it says, whoa, wait a minute, that's what right bank is. Well, because we have all this proper, it's actually calibrating properly. Now I'm going to push forward. This is what they call nick. I think in German, forward or pitch means nick or down. I'm going to pitch this forward. Now I'm going to go to my yaw, push yaw to the right. Now I'm going to rotate this to the right. There we are. That would be how you do a setup. So if you had this mounted 90 degrees, all you need to do is do that setup, and instantly it's going to reassign your gyros. You don't need to do offset adjustments or anything like that. It's a learning system. It knows what right is. It knows what right input is. It matches them up. It's a really cool thing. Once again, antennas forward, facing up. You don't need to do that, but I just love that feature, and it works really well. So now the last thing we're looking for is ESC calibration, because not all ESCs are going to be created equal. The last adjustment we're going to want to do is we're going to want to go down below quadro, which is quadcopter, which is quadcopter. You see mode, it says normal. We're going to switch this mode, and we're going to go up once or down to ESC set, and then we're going to hit enter. Now, I'm going to go ahead and I'm going to power this down. I'm going to give full throttle here. I'm going to plug it in. You're going to hear 2 beeps. Throttle down. Now when I give throttle, everything's perfectly timed. Now this was already pretty spot on, but this is a setting I would strongly recommend doing whether you're using RE packs or whether you're using anyone else's electronics. Do this setup and get them all running even. If you don't have them running even, you're going to have a great amount of difficulty getting it to pick up. It'll kind of pitch and then it'll catch. You don't want that. Now that we have our ESC calibration done, we got to go ahead and put it back in normal mode. So just to get all the way out of here and show you what we did. So now we're going to go back into settings and data. We're going to go and scroll all the way over until we see mode again. Right there. Now we're going to scroll down, highlight this, and we're going to put it back into normal mode. This is going to make you capable of flying. So now we'll unplug it. We'll turn this off. And let's go to our last feature. We're going to turn this on again, turn the transmitter on, plug it in. You'll see we instantly have a telemetry link. Now, with our propellers, we want them to spin inwards. The easiest way to remember is whatever orientation, if it's facing away from you, the props are going to spin inwards. So this is the direction we want to see. So let's give it a little throttle. This one's right. This one's right. No way. Okay, this has never happened, ever, but every single one is right. But let's show you what happens if one was wrong. As you see, we're powering this up, and this is spinning the wrong direction. You can also use a piece of tape here if you want. Unplug 2 of the connectors, doesn't matter which 2, and switch them. The way that works is if you're energizing field A, B, C, A, B, C, and you switch just 2 of them, what happens is you go B, A, C, B, A, C, B, A. It just reverses the way that the thing energizes. So it has to do with patterns. I'm going to tuck these back in, get my wires nice and dressed up again. Confirm one last time everyone's running the right way, and it is. Now, when I energize this, what I should feel, when I go forward, the back one speeds up, the front one speeds up. Now when I go right, this should speed up. And then when I yaw right, it should speed up. And that's because the torque of the motor is going to drive it to the right. So at this point, everything's ready for the props. Before we put our props on, we're going to take this to the edge of the table. I'm just going to hold this flat, and I'm going to center these up and push it flat against the table. That's going to give me a perfect horizontal motor. Same this side. Make sure everything is nice and flat. These aren't turning. Perfect. And then I'm going to follow up with a little drop of CA inside the open cracks and let that flow. Delrin's very fatty and CA doesn't glue to it, but what it does glue nicely to is carbon fiber. And by putting it in the cracks, you're going to make a little tiny key of glue. And under a hard impact, it'll break loose. But under general flying, it's going to stay nice and firm. Now the next thing we're going to do is we're going to talk about cameras. Now this can actually mount where a GoPro could sit right up here. And that would strap through here. Or you can mount a Mobius. And in that case, the strap goes right around here. You can see it doesn't hit the buttons. Or you could simply put a board camera on it. Or we have a lot of other options. We have things like standoff kits. We have extra plates. We have the AP rail system, both in the long version and the short version. This is probably the easiest, and if you're starting out and you don't mind flying through the GoPro, one of the quickest and most fun ways to get in the air. This is the plate that's off of our AP rail system. One thing we're really trying to do is keep everything compatible. So you may buy this separately, but say you get an AP rail system in the future, this will bolt right onto it and slide right into it. You can see you have 2 different slots here. One slot is for if you have the GoPro 2 or GoPro 3. This also fits all the Boz cams, just depending on how you mount it. But in this case, the only way we can mount it is this way here, and you can see that fits the GoPro. So what we're going to do is we're actually just going to mount this right on the bottom here, hard mount it, and that way our GoPro can sit right up on here. And I'm actually going to take 2 little simple grommets you can find at the hardware store, and I'm going to put a cushion. A lot of people do different things. I prefer using a little bit of cushion and angle this back, so when we're flying forward, we have a nice level shot. But if you're just starting out and you have auto level, you can go flat as a pancake right here. Other ways you can option this too is we also carry a standoff kit with lots of different style tubes and different length tubes. You can actually sling this down. You can oversling it and have it hang down and then put your board camera on the top. There's many different variations. We're going to show you those in little supplemental videos in the future as we do more builds. But right now I'm just going to show you the simplest, easiest one if you're just getting into racing now. Tighten the tube down enough. This is going to be exposed just enough to bite the nuts. Now everything that we want to think about whenever we're putting additional pieces on, whether it's bobbins, whether it's standoffs, whether it's plates, is we want everything to be able to be accessible. So if God forbid we crash, we can lay it flat on its back, take out our little nut driver, remove the screws, open it up, service it, put it back together, and be back in the air in no time. So I'm just going to tighten this down. Just enough to bite into the nylon washers. You don't have to go too tight. And now I'm going to go ahead and put the other 2 nuts on the back. We still have the middle ones in, and finish tightening them then. Now we were talking about how you can do all your settings here. You change your multi-rotor type, you can change your PID settings, you can change your attitude settings. If you activate channel 5 on your MZ12, that is your rate mode, and your ADDI mode, we'll do that right before we fly so you can see both modes. And you can see I really don't need to have a 2 mil bit on the other side because it's threaded in here. It actually locks down beautifully. Alright, at this point we're going to go ahead and put our propellers on. And just like we were talking about orientation, I'm going to go ahead and lay these out in the order that we need to put them on. We want these spinning in, which means we want the heightened edge that's biting to move forward, just like you would on an airplane. Numbers up. And there we are. Now, if you just loosen this and drop these propellers on, these are 645 propellers, you can see they're loose. It's really important that you use these little spacers. These are precision spacers. The one we're going to use is this one right here. So that'll fit over. I just use the prop and press it down. Now you can see there's no wiggle. Throw that one to the side. This is a reverse thread, so that way it's not righty tighty, it's righty loosey. Propeller goes on. So loosey tighty on the black nuts. Now in the future, we are going to be carrying, one problem is when you lose these reverse thread nuts, they're very difficult to find. We currently carry them, and we're also in our store going to be carrying replacement nylon knock nuts that are actually CNC'd. We're going to have those available very soon. Probably by the time you're watching this video, they'll be in our store. This isn't so much for a plug, but the reality is sometimes you lose a nut. Sometimes you're just replacing a prop and you drop a nut. The reverse ones are very difficult to come by. And what we found is a lot of people prefer just to have everything standard thread, and that way they can easily replace their nuts and have access to these nuts. So we are going to have replacements for both reverse and normal, but if you're watching this video and you get a kit with all silver or all standard thread, that's generally where everyone's moving towards. The idea behind having the reverse thread is if you hit something, the prop wouldn't fly off, or the torque of the motor running up and down wouldn't slowly loosen the prop. It's a very, very good concept, but lock nuts and tightening these down do a really good job too. And the last thing we want is people having to buy a whole new motor because they can't get that. So now we're going to go ahead and tighten these up. Black will tighten to the left. Silver will tighten to the right. And at this point, you always want to be cautious about starting your motors. This doesn't have a typical arming sequence. This arms much like a smaller multi-rotor. Now you can just throttle cut where it's on a switch, and then you have to flip a switch to arm it. That's a really nice feature. Frankly, I kind of like being able to power this on, leave it still, and know when it's armed. But if you want to go to throttle cut where you have it on a switch, you can easily program that. It's in the manual. We'll have a link below. The only other thing we want to do right now is we want to activate channel 5 onto a switch. This is going to be able to take us, right now it's defaulted in horizon mode, which means when you take off your hands off the stick, it'll automatically level. We want to make it so we can go from horizon mode to acro mode. So I'm going to turn this on. It's going to want me to ask me if RF mode is on. That means it doesn't want to speak to a receiver. I'm going to say turn it off. Now I'm going to go down to, what is it? Control settings. Right here. And you see I5 is free. I don't want to make it free. And I think I want my level to be on this switch right here. So what I'm going to do is I'm going to activate this. It says flip your desired switch. So now we have on and off. This will give us our acro mode and our horizon mode. If you want the switch in a different position, all you simply need to do is reverse it. Alright, last thing we're going to do is I'm going to leave the lens cover on my GoPro, but I'm feeling pretty confident on this. I'm going to show you guys how to make a really quick, simple little fastener. I'm going to take this Velcro strap. I'm going to pass this through. I'm going to take a little bit of hot glue right here. I'm going to press this down in. That way when I put my GoPro on, I can cinch this down, pull it tight, and slap it on. So I'm just going to put a little bit of hot glue down. Right there. Keep in mind the heat's going to pass right through this. I'm actually going to pull this a little bit beyond it, and I'll cut off that excess. I'm going to hold this firmly until it dries. Now I was talking about grommets, where you can put grommets on. This is something very simple. These are actually on our AP rail system, so we have them laying around everywhere. Also, if you use servos, this is a very common thing that's a vibration dampening for servos, especially on the bigger servos. So some people may have these laying around, but you can also get these at Lowe's hardware stores. They're about 5-10 cents a piece. You get a bag for $1. But I like to hot glue these down, so when I set my GoPro down in here, it's almost like little miniature bobbins. And then you can strap that down in here. Got a little bit of vibration dampening, and it holds your GoPro at a nice angle to fly forward. With this one, I'm not going to worry about that too much. I'm just going to go ahead and go nice and flat on it. If you're a hardcore racer and you fly really, really fast, most likely you're not going to be using the GoPro. But for a beginner, going through a GoPro or Mobius, you do have lag, but it's not noticeable enough if you're not flying too fast. And we've cut through trees, I've raced races. You're talking about milliseconds. When you really start learning and going fast, milliseconds are going to definitely count. But for right now, this is a very simple, easy way to get through, get up in the air, and get going. All right, let's go out and fly it. All right, friends. Well, she's all buttoned up. The props are tightened. A couple things I went through is I made sure that all of our screws are nice and tight. When I say tight, it doesn't mean to the point where it's going to break things. I mean snug. You want this to have a little bit of give to it. It doesn't need to be super tight where it's deforming things. If you see things that are deformed, you've over tightened it, loosened up just a little bit. The other thing too I want to show you is with multi-rotors, it's really important to monitor your battery voltage. Oftentimes you're having so much fun you get lost. Don't be like me and puff batteries. Use a little voltage alarm here. This is a simple little $5 one we got in our store. And plug that in. And what I do is I got prickly Velcro here, I got fuzzy Velcro here. I just stick it right on the battery. That way it's not flopping around. A lot of these this is a Lumineer battery. A lot of these great batteries have short leads now on them, so they don't get cut as easy. But that also means you don't have as many options of where you want to put things. So I'm going to go ahead and put this on the ground. I'm leaving the lens cover on my GoPro for right now, because in case something does go wrong, I don't want to break it. If you guys are nervous, don't put a GoPro. Counterweight it, move your battery forward, and balance it out neutral. It'll balance perfectly neutral with it all the way forward. I'm going to turn on my radio, and I'm going to plug this in. 3 beeps means it's ready. Right now I'm on default mode. That's horizon mode. That's the switch right here that we programmed on channel 5. So it should take off in auto level. All right, so I'm just gonna get it spinning. One thing I like to do before I take off, just bump the controls. You can see it wanting to do a right bank tendency, left bank tendency, forward, and y'all, you can't really tell, but if that's looking good, you're good to go. If you did this and the gyro was backwards, they would immediately somersault. That's why it's really important to step back. Everything sets out good. Let's go ahead and hover it. That's nice. All right, let's take it for a spin. Now this is in horizon mode with a limit on the bank angle. So right now, it's only giving me about a 35-degree bank. Very, very smooth though. Now this is not how you'd want to race, but if you're just learning to fly multi-rotors, this is excellent. Let's give a punch out. And decel is nice and smooth. All right, let's go ahead and flip it in acro mode. Now with acro mode, you're going to be able to turn a lot quicker. And this isn't with any rate gains or changes at all. Even in acro mode, it's still very nice. So this is a 3-cell setup on a 2200. You could always go to 4-cell, but I would strongly recommend if you're going to 4-cell, go with the Lumineer power setup. And we'll have that link below. And you see decel is just beautiful. This doesn't have one shot on it, so this is not working off a one shot. It's still very locked in. When you tip it forward, it stays right at where the head is going. So I'm really happy with this, but what I want to do is I want to see what it looks like through the goggles. So I'm going to land this, put a new battery in, and we're going to go ahead and fly at FPV. All right, so I went ahead and I took off the lens cap number 1, but also I really like to fly forward a little bit faster. So what I did is, you can see this little white piece of foam rubber. In our little electronics case, there's this really nice spongy white rubber. All I did was cut a little section off of it and hot glue it underneath here. So if you buy a video transmitter or you have any of this stuff laying around, even if you got the 2204s in the case, it has the same material as this. It's really, really good to give yourself a nice vibration dampening, and you can also adjust your angle here. So that's just a little quick tip for you. So the best way to tune your multi-rotor is to fly it. Now I'm flying the linear polarized, or I'm sorry, the linear antenna, and it's actually still really solid. Now I'm flying in horizon mode. Let's get out of horizon mode. There we are. So at the very most, I think I just need to drop my P down just a little bit. But this is by far way more dialed in than most of the times I fly. Let's go through the trees and see if I can crash it. Alright, so just a very minimal amount of tuning, maybe a little bit with my D and a little bit with my P. I got slow oscillations, but all in all, very, very nice. Woo! Let's go over the trees. Woohoo! I don't know what it is about going over trees, it's just so much fun. There we are. Friends, I want to thank you for watching. Thank you for being part of the Flite Test family. If you're just getting into multi-rotors, just getting into racers, this is a really good setup. Also, the way we design this is we really want this to go into schools, into different youth centers, different groups, where people can get into the hobby together as a group. Hopefully you find this experience good. Let us know your feedback, and we'll see you next time.